Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In my last video, I showed how you can display graphics without any gaps in between them. And this allows you to make a bigger picture, out of lots of little pictures. So for example, you could display an environment using lots of little tiles, each of which represents one particular possible type of terrain. In this video, I've taken that idea one step further. As you can see, I have a character, and the character is in this little environment, and we have these buttons, north, south, west, and east. And if I decide to click on west, the character, there we go, the character moves west. And I can keep clicking on that and she will move, and everything is consistent. The environment changes as it should change. You'll also notice that when she can't go in a particular direction, that button doesn't have a letter. So there's no W here because immediately to her west is wall. If I go south, well, now she can't go west or east, so both of those buttons are blank. But if I go, say, over here, then she can go in all directions. So that's what I've done. Let's have a look at the code. Okay, so I will zoom in a little bit. So the first thing we do is we set up how many squares this environment's going to be, left to right and top to bottom. And I've decided to make it 20 by 20, so it's a very small little, I'm going to call it an environment. You could call it a level or an area. Then we have, so that's what X and Y are. They're the dimensions of the world as a whole, or the environment as a whole. Then we have CX and CY, standing for current X and current Y, which give the location of the character, and the character starts at 1010, so roughly in the middle. Then we have a variable which tells us how many squares we're going to display. It is $dr, which stands for display radius, and it's set to 2, and it means that we display squares up to 2 squares away from the character in all directions. In other words, we'll be displaying a 5 by 5 grid. Then we have the array E, which is going to be a 2-dimensional array, and it determines what sort of terrain a given square is. And this is a very simple environment. 1 means that square is a wall, and 2 means that it's grass. And you can't move into walls, and you can move into grass. This array doesn't keep track of where the character is. We do that with these 2 variables. So grass with the character on it is the same, at least as far as E is concerned. That's the same thing as just normal grass. It doesn't make a distinction between where the character is and other open areas. So then we have XMI, XMA, YMI, and YMA, which stands for X minimum and X maximum, Y minimum and Y maximum. If we're going to display a 5 by 5 square, we need to know which section of the whole environment we want to display. And normally it will be centered on the character, of course, because we want to show where the character is. But these numbers will determine that. It's not quite as simple as saying, well, go from, you could say, well, why don't you just go from CX minus 2 to CX plus 2 and CY minus 2 to CY plus 2. Well, normally that is what we'll do, but there's a few cases where that won't be the case. Essentially, if the character is in a corner, we won't quite be doing that. So that's why we need these separate variables, and you'll see that in a second. Then, as usual, we have notes that I'm going to be using temporary variables. Normally, this list would include y and x, but we're using y and x to be the size of the environment. So having set up all these variables, we then go to set up the environment. This way of setting up the environment isn't particularly realistic. You would probably have a lot more elaborate an environment for a start, and you would probably have some randomness so that the game was slightly different each time, perhaps, and you might have sort of predetermined levels, so you would just have an array and you would just write in the data because you want it to be a very specific thing. You need the lever to be here, and you need the palace to be here, and you need the drawbridge to be here, and etc., etc. But anyway, this is good enough to demonstrate what we're doing. So we have a for loop which goes from 1 to x. We set Ez to be itself an array, so this is how we set up a two-dimensional array. Then we have another for loop for going from 1 to y. Then we have a fairly elaborate bit of code. If one of these things are true, we set EZW to 1, and if none of those things are true, we set EZW to 2. Remembering that EZW equals 1 is the same thing as saying that EZW is a wall, that particular square is a wall. So when is it a wall? Well, if Z equals 1 or Z equals X, or W equals 1 or W equals Y. So those four set up a... Sorry, I highlighted the wrong thing. There we go. Those four set up a wall around the borders of the environment. So it's kind of like a walled, kind of like a courtyard or a garden or something, a walled garden. And then within the environment, we have this. If $Z %3 is equal to 0 and $W %3 is equal to 0, then that will also be a wall. So what that means is if this is to do with remainders. This percentage means the remainder when something is divided by something. So what this means overall is if the remainder when Z is divided by 3 is 0. So in other words, if this particular one, it's saying if Z divides evenly into 3, if it's 3, 6, 9, 12, 15. And if $W %3 is equal to 0. In other words, if it too is an even factor of 3. And so what that does is creates little sort of single square walls interspersed evenly throughout the environment. Because if I hadn't done that and you just had the wall around the boundary, if you were moving around, you couldn't tell because everything around you would be grass, and there's only one tile that represents grass, so you wouldn't be able to see any movement until you came to the wall. So we want some sort of features inside the environment that change, so you can see that you're moving around. So having set up the environment, we then go to display, and the way the program works is it basically uses these two screens from now on. The player, when they move around, that just brings them back to display. So first of all, we get back to this XMI, XMA, and YMI, YMA stuff. And I said before, well, why don't you just use, instead of having XMI and XMA, why don't you use just CX minus 2 and up to CX plus 2? Well, this will explain why we can't just do that and what we're doing instead. So we do start by saying that XMI is CX minus DR, so the current X minus 2. And we do say that XMA is the current X plus 2. But there are some special cases where we need to slightly adjust them. And the special cases are if xmi is less than 1 or if xma is over x, because we've only defined the environment. The environment only really exists between the values 1 and x. So we can't really display what's happening with squares with an x value of 0 or what's happening with squares with an x value of 21 or more, because we haven't really defined anything happening there. So if we end up in a situation where cx minus dr is less than 1 or cx plus dr is over 20, then we need to fix that. And that basically means if the player has moved the character towards towards the sort of outer edge of the environment. So let's look at the case where xmi is less than 1. What we do in that case is we set xma equal to xma minus xmi plus 1, and we set xmi equal to 1. Now, this maths isn't very intuitive, or at least I don't find it so. So I'll go through an example that'll show you why it works. Let's say that cx is 1. Cx can't be 1 in this particular environment, but let's say that it was. Let's say that cx, excuse me, let's say that cx is 1, then that would mean that xmi was 1 minus 2, which is to say minus 1, and xma would be 1 plus 2, which is to say 3. And so we would have a problem there because the minimum x value is minus 1, and we can't display anything with an x value of minus 1 or 0. So we set xma equal to xma minus xmi plus 1. So 3 minus 1, which is 4, plus 1 equals 5. And then we set xmi equal to 1. So minimum value of minus 1 and a maximum value of 3 becomes a minimum value of 1 and a maximum value of 5, which is the same range, minus 1, 0, 1, 2, 3, 1, 2, 3, 4, 5. It's the same size, but it's now limiting itself to the corner of what we've actually defined. Similarly, let's say that cx was 20. Again, that can't happen, but it makes for a clearer example, or can't happen in this setup. Then we set xmi equal to xmi minus xma plus, xmi becomes xmi minus xma plus x, and xma becomes x. So let's say cx is 20, then xmi would be 20 minus 2 is 18, and xma would be 20 plus 2 is 22. And again, we would have a problem because we can't display anything with an x value of 21 or 22. So we set xmi equal to xmi minus xma, so 18 minus 22 is minus 4, plus x, so that would become 16, and then xma would become 20. So instead of 18, 19, 20, 21, 22, we would have 16, 17, 18, 19, 20. In other words, we would be displaying sort of one edge of the boundaries that we've set ourselves. We'd be staying within those boundaries. And then we do exactly the same for y. I won't go through the code here, but we similarly need the y values to be within that range. So that is how we get xmi and xma and ymi and yma and y. It's not exactly the same as just getting the current value and minusing or adding dr. Having done that, we then set up an array, a table, sorry, not an array, we set up a table, a HTML table. And it's a 3x3 table. And I'm just going to do a little quick sort of picture of it. So if we imagine that I have a 3x3 grid like this. Makes sense. I have a 3x3 grid, and as you have probably picked up by now, we're going to do that by making with TRs and TDs, which we very commonly use. So in the corner cells, in this cell, this cell, this cell, and this cell, there isn't anything. In this cell, there's the arrow to move you up. In this cell, there's the arrow to move you right or west. In this cell, there's the arrow to move you, sorry, that one moves you east rather than west. This one moves you west. In the bottom cell, I don't know if there's a character for this, but anyway, in the bottom cell, there's the down arrow. Just put a hash. Sorry, I know that's not a very satisfactory solution, but anyway, so we have a 3x3 grid. We have nothing in these corner cells, so we can just I'll just look. And then in the middle, we have the main display. In the middle, we have that 5x5 set of tiles, which includes the characters and the pictures of the grass. So this cell here, the middle one, is much bigger than the others. These outer cells are all quite small. This one is quite a lot bigger. It's actually the main display. It's almost, and it is a 5x5 grid in itself as well. So this is the structure that we're using. I actually had a very similar structure in a previous, when I was doing a sort of demonstration game called Into the Underworld. I had the main display in the middle and then the 4 arrows to help you move. And I'll just go through this quickly because it's basically the same code with some slight variations 4 times. So we have TR, TD/TD, that's that empty cell. TD align equals center, so this is going to be a centered cell. If E CX CY plus 1 is equal to 1. In other words, if the square immediately to the north of the character's current location is a wall, then we do this, and if not, we do this. And what we do, what this is we just print a image, and the image is called button NS, and it's just a blank button. It's the north or the south button, but without any letters on it, and it's not a link. It's just a dead image, as it were, to show you that you can't go in that direction. Or if the way in that direction is open, then we do this. We print a more complicated thing, and you'll recognize this structure as a more complicated image command where we have image or square bracket img square bracket. Then we have the location and the file name. Then we have where it's a link and where it goes to. And then we have what variables change when it is clicked. So there's 3 different bits here. The picture is called button N. So button north, it's the button with an N on it. Where does it go? It goes to display. In other words, it goes right back to this screen. And what do we change when we click this button? Well, as you'd expect, it moves you north 1 square. And how do we move north 1 square? Well, we turn CY to CY plus 1. In other words, change the player's, change CY, so it's 1 space north. And then we have very similar code, which I'm not going to go through, for all of the other directions. The difference is which we look at the square immediately in that direction, and we say, is that a wall? If it is a wall, we just print a blank button. And if it isn't a wall, if it's open space, then we print a link. And then in the center of the array, we have this include main display. And I've put that on a separate screen, on a separate page, sorry, because I think it's a lot easier to explain. It's sort of quite complicated in itself, and so it's probably worth doing separately. And so then we have, this one's the button that goes west. No, sorry, this one's the button that goes east. Now you'll notice that I have button NS is the blank button that goes, that is used for both north and south, because they look the same. Without the letter, they look the same. All we need is a vertical, no, sorry, all we need is a button that is wider than it is long when it's going north-south. And similarly, I have button EW, and that is used for when you're unable to go west and when you're unable to go east. Because again, all we need is a button that is higher than it is wide. Without the letters, they are the same button. So that's the sort of overall display. And then let's look at this main display. And this is very similar to the code that I showed you before, as in my previous video. So this is one of those things where we have a variable, and we're going to keep, and the variable is a string, and the string is quite a lot of code, and we're going to keep adding to that variable, and then at the end we're going to print it. And the reason we do that rather than printing as we go is because if we print as we go, sometimes Twine has a bit of trouble matching things up. So it might say, well, you've got a div here, but I can't find a slash div. I have found that if you get it all in one long string and then print the string all at once, it can cope with it. It goes, yes, I see that this div relates to this slash div. So we start by generating something like this: div style equals quote. That slash quote just means a quotation mark in the string. Width. Then we say 2 times dr plus 1 and then times 48. Well, why is it times 48? Well, it's times 48 because the pictures that I'm using happen to be 48 pixels wide and 48 pixels high. Why is it 2 times dr plus 1? Well, because dr is 2, and that means we're printing a 5 by 5 grid. So to get from that 2 to the 5, or from, if dr was different, we might have dr was 3, and that would mean we printed a 7 by 7 grid, for example. Then you multiply dr by 2 and add 1. So in this case, it'll be 2 times dr, so that'll be 4, plus 1 is 5, and then 5 times 48, whatever that may be. So a little bit less than 250 pixels. I wouldn't say 2. So it'll be something like that, and then it'll be so we're going to set up a div. At the very end of it, we're going to have a slash div to close it off. And in the middle, we're going to have a lot of pictures, basically. We're going to have image style equals, and I'll show you what it looks like. So we have for loops, as usual. For z equals yma up to z starts at yma and goes down to ymi. So it starts at the maximum and goes down to the minimum and goes down by 1 each time. So why does it do that? Well, because of the way that we number squares on a grid. 3, let's say you're on the square 2, 2, and you go 1 square north, that's the square 2, 3. In other words, going up or north increases the y value. So because we're printing from the top down, we start with the high y value and we go down. Whereas the x value does what you'd expect, starting at the minimum and going up to the maximum by 1 each time. Because, again, that's how we number. We number grid coordinates. If you're at 2, 2 and you go east or to the right, then you end up at 3, 2. In other words, moving east increases your x value by 1. So we go through everything from xmi to xma and from ymi to yma, and we have various possibilities. If cx is equal to w and cy is equal to z, in other words, we've got the square where the character is, then we're going to print this, which will be something like image style equals height 48 pixels, width 48 pixels, float left, src, which is source equals art slash character.png. And then the other possibilities, we say, well, if that's not the case, and we know because the character can only move on the grass squares. They don't have the option to move into the walls. If this was a proper game, that might not be true. Perhaps there'd be some sort of spell that allows her to have a sort of ghostly form and move through walls temporarily, and therefore we'd have to have some more complicated code to tell us, do we print a picture of the character with a wall behind her, or do we print a picture of the character with the grass behind her? But in this particular case, it's always going to be grass. So we just need a single thing. If we've found the coordinates of the character, then print character.png, which is just the grass tile with the character picture put on it. Otherwise, if EWZ is equal to 1, which is a wall, then print or add all of this to V to be printed at the end. And this is very, very similar. Now, you'll notice that because most of this is the same, what I could have done is, instead of saying, if this is the case, set V to this, and if this is the case, set V to this, and if this is the case, set V to that, what I could have done is I could have started by saying, set V equal to all of this. I could have had that. I could have had that up there. Oops, sorry. Oh my goodness. Sorry, something's gone wrong with my cutting and pasting. Oh my God. Sorry, this is a very old computer and it's not always a what? All right, I'm not going to try and make it do what it's meant to do. Seriously, guy, just... Anyway. So what I'm trying to say is I could have had all of this code up here and then just had the bits that are different down here, which is just the name of the file. It's character.png and wall.png and grass.png. I chose not to do that because I thought it'd be better to have a slightly more redundant bit of code that was a little bit easier to follow. All right, so if it's a wall, of course, we print left source equals art slash wall.png, and then if neither of those things apply, then we're going to print the only other option, which is the grass tile. And that, once we go through that 25 times, we will have printed the immediate environment of the character, and you'll see what you saw at the beginning of this video. So I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.